All right, guys. I'm hoping that this is going to help you after lesson 4. I think it was a very confusing lesson, but hopefully this will give you some practice. Do yourself a favor as I start talking. If you want to go ahead and try some of these on your own. Some of these are the same examples we did in class, but let's get started. First of all, I wanted you to do two things for these problems. One, I wanted to know what the missing term was, and then also I wanted you to put it in factored form. And this is all based on knowing when something is a perfect square. Well, if you take the square root of the a and the c terms, taking the square root of 4 and 4, you get 2. And you multiply those together and then multiply those by another 2. And again, it's just coincidence you always use that 2. These numbers don't have to be 2's though. You should always end up with that middle term. And 2 times 2 times 2 is 8. And it's okay that it's negative 8. That just means that this comes from 2x squared, or I'm sorry, 2x minus, in this case, 2 squared. And if you multiply 2x minus 2 times 2x minus 2, you will indeed get this, this expression. So if you built a square, a 2x with a negative 4, and another length of 2x's with a negative 4, you can build that, and inside would be all of these. You'd have 4x squared, you'd have 8 negative x's, and you would have 4 little left over as well. So knowing that this right here is based on these two together times square rooted times 2 will get you 12, I divide by 2 to know that this times 2 would get you 12. So this is already a 1. So 1 times something times this 6 times this magic number gets us 12. Well, I know that if you square this, you get 36. So this, just to check, 36, here's the 6 that we got, times 1 times 2 would get you 12. So the mystery number is 6, and if I square, you would have to square root it to get that 6. So I know I could go the opposite way and square it to get 36. Here, same kind of concept. I know that this number comes from taking 2 times the square root of this number, and this is a 1. Square root of 1 is 1. So 2 times 1 times some mystery number got us 14. So what would that mystery number have to be? Well, that mystery number had to be a 7. 7 times 2 times 1 is 14. Well, if I took the square root of this number, to get 7, I go backwards and know that it's 49, because the square root of 49 is 7. And that's the only way I could have got negative 14 there. For these two problems, to find the factored form, I could think of this two ways. Essentially, what you're doing is, how would you get x squared? Well, that's x times x. And what number times the same number will get you 36? That's 6. And because it's plus 12, I know that there's a plus between them. So x plus 6 times x plus 6, or in other words, x plus 6 squared. Here, it's minus, so I know it's x minus, and the square root of 49 is 7. So x minus 7 times x minus 7, or x minus 7 squared, will get us the factored form. These two things are the same. Here, the middle term, remembering that this comes from 2 times the square root of this number and the square root of this number. Square root of 1 is 1. Square root of 100 is 10. 2 times 1 times 10, you get plus 20x. And the factored form, well, how do you get x squared? It's x times x. How do you get 100? 10 times 10. And because it's plus, we got a plus 10. And if you multiply these two together, you'll get x squared plus 20x plus 100. Here, square root of 4x squared is just, is 2x. Square root of 81 is 9. So remember, 2 times 9 and then times 2 again is 36. So this is minus 36x. And since it's negative 36x, we're going to say that the factored form is 2x minus 9 times 2x minus 9. Or in other words, you could just say 2x minus 9 squared. So today in class, we learned about how if you have something in basically vertex form, such as x minus 3 squared plus 4, it's really easy to talk about the graph because you could know what the vertex is already. The vertex is at 3, 4 because it's already in vertex form. And then when you go to draw it, you know all of these properties about that graph. Got the domain, the range, when it increases, when it decreases, This should actually be the minimum is 4, because it gets to a, it gets to a certain low point and then goes back up. And that low point is at 3, 4. So this is actually from lesson 2. But, you know, the point is that you can really understand this if it's in vertex form already. Well, if you have a graph like x squared minus 6x plus 9, that's not in vertex form. So it might be at first hard to graph. But if you think about x squared minus 6x plus 9, that would be, there'd be 6 of these negative x's. There'd be 1 of these x squareds. There'd be 9 positives. From this last lesson, you might notice that the square root of 9 is 3. Square root of 1 is 1. And 1 times 3 times 2 gets you this middle term. This actually is a perfect square. And if you went to go graph it, it would look just like this. X minus 3 times x minus 3. And you can see that when you combine these, they could combine to be a perfect square. Here's the 9 positives. Here are the 6 negatives. And here's the 1x squared. And I put them together in a square with one length of the side as x minus 3 and the other length x minus 3. So we could think of this, instead of x squared minus 6x plus 9, we could think of this as x minus 3 squared. And even though I just put this in, essentially factored form, this is the same format as when you have vertex form. So now I know, which I didn't know originally, that the vertex is it's the opposite of what's inside the parentheses, so the vertex is at 3, 0. I would have found out the same answer if I didn't put this in vertex form, but I used what we learned in lesson 2, which was finding the vertex. You can use negative b over 2a when something is in standard form. This gets you the x-coordinate of the vertex. And look back at lesson 2 to just to remind yourself of how we use that. But this is just another way to find the vertex without having to use this formula. So if you get x squared minus 6x plus 9, you can easily graph it because now we know it's y equals x minus 3 squared. You still have to find a couple of other points by just plugging in x's that are to the left or right of the vertex. And just for practice, go ahead and of that last graph right here, tell me all the different properties that you learned about this graph. So what I'm asking you to do is, just like all these things, this line of symmetry, the increase, all the things that you learned in lesson 2, go ahead and pause the video and write everything that you can say about this graph. Okay, now hopefully you did that, and here are all the things you should have said about that graph. Translation, and you could just go ahead and read these and make sure that this is exactly what you had. So of course, it's a lot easier when something is in vertex form. So here is an equation, y equals x squared plus 8x plus 10. And if you remember what we said about a perfect square, this is not a perfect square. And in fact, if you go to try to draw, 1x squared, 8 of these x's and 10 of these, you can see that it doesn't actually form a square. But there may be something that you may be able to do to actually add some stuff so that it actually does become a square. We call that completing the square. And so we think about how do we do that. All right? So we're going to talk about a second how we do that. So the equation was y equals x squared, I forgot the equation already, plus 8x plus 10. And so, again, you could find the vertex in order to graph it by using this formula to find the x-coordinate and then plugging the x back in to find the y. But another way we could do that is think about how can we make this a perfect square? So instead of x squared plus 8x, what I think to myself is, what can I make that last term to be that perfect square? So, and remember, we did this in the very beginning. This 8 comes from the square root of this number, 1, times 2, times some mystery number. So what number does this have to be? Well, what times 2 gets you 8? It's be 4. So if you think about it, this number square rooted has to be 4, which means this number has to be a 16. So the way that you can get this to be a perfect square is to make sure that the last number, the c, is positive 16. But it's not positive 16. It's positive 10. So what I have to do to create that to be positive 16 is I'm going to add 6. But we have to remember that we added 6 because you don't want to change the actual graph. We want to keep it to be mean the same thing. We just want to complete the square. Well, now that you completed the square, I can take this and put this in factored form, which would be x plus 4 squared. But remember, in the very beginning, we added 6. So we have to account for the fact that we made this actually 6 bigger. So at the end of the problem, even though I was able to factor this because this is a perfect square now, I want to take away 6. And what you just did was you turned this into vertex form. By completing the square, you made this into an equation that I'm actually you could easily graph it now. Now I know, even though I didn't know it from the beginning, the vertex is at -4, -6. Let me show you another example of that. Or you might be able to actually, if you already get it, you can try this on your own, pause the video. But if you can't, go ahead and try these with me. All right? X squared plus 14x plus 10 is not a perfect square. And if I want to complete the square, I need to think about what would I have to make that last number. And half of 14 is 7. 7 squared is 49. Because just to double check, square root of 49 is 7. Square root of 1 is 1. And 1 times 7 times that 2 is 14. So I've just made this a perfect square. So x squared plus 14x plus 49 can be put into factored form because it's x, it is a perfect square. It's x plus 7 times x plus 7. So I can make this x plus 7 squared. But in the very beginning, this c was not 49, it was 10. So I actually added 39 to get to 49. Well, in the end, I need to take it away now. So now our vertex form is y equals x plus 7 squared minus 39. So now I know the vertex. The vertex is at -7, -39. Go ahead and pause the video for the next one, or you can watch with me. Here, I want to turn this into vertex form by completing the square. So x squared minus 8x plus 20 is not a perfect square. But if I take half of -8, or 1 times 2 times what number would get me 8? Well, that had to be a 4. The square root of 16 is 4. So now I've completed the square. So it was 20, but now it's 16. So this, because it's now a completed square, can be factored into x minus 4 squared. The reason why it's minus, remember, is there's a minus in front of the 8x. And again, if you do x minus 4 times x minus 4, you will get back at this. But now, remember, to get from 20 to 16, we subtracted 4. And I want to keep the problem the same. So at the end, I'm going to now add 4. And now I have it in vertex form, and I know the vertex would be at 4, 4, positive 4, even though it's negative and it's the opposite. All right? I hope that helps with today's lesson.